The Earth has been our home for millions of years. However, sometime soon, the Earth may no longer be our only home, and we will start to spread out, searching for new places to live. It's possible that in the near future, the Earth could become uninhabitable due to climate change or overpopulation.
Sooner or later, here on little planet Earth, we're going to meet an unhappy end.
As a result, we may need to move and create a new home in alternate, distant space colonies.
Really, in the coming years, there will be several activities on the surface of the Moon.
The recent discovery of huge amounts of water in the Moon's poles and on Mars has encouraged public institutions as NASA or the European Space Agency and private companies as SpaceX to lead projects that will let us to settle in such distant and harsh environments in the near future.
We could see Mars colonization in our time. We could see it much sooner than most people think.
Another option might be a future settlement in an orbital space colony, or even on a nearby asteroid. In any case, it's not an easy task at all. We would require habitats, storage facilities, shop workspaces, renewable energy sources, food production spaces, and equipment. In the Moon, we would need to solve huge difficulties such as the low gravity, the exposure to lethal cosmic radiations, or the lack of atmosphere.
You're over 100 degrees Celsius during the lunar day. And then when you go to lunar night, you're minus 180.
In Mars, the difficulties are even more challenging due to the increased distance from Earth, which implies a much longer interplanetary spaceflight of about 6 to 9 months. This is too long for astronauts to be exposed to zero gravity and lethal cosmic radiation. The unstoppable technological breakthroughs suggest that in the near future, we will be able to overcome all these challenges.
That is going to create the greatest industrial revolution in the history of mankind. And we're standing right here at the moment in history when it's about to happen.
Our descendants who might live on the Moon or Mars will remember the moment they established the first space colonies as one of the greatest milestones of humanity. Human beings have always been fascinated by that mysterious dark space outside Earth. The beginning of the colonization of space may be dated to 1957, when a first historic step took place that would mean the beginning of the space race.
In the late 1950s, 1957, the Soviet Union put an artificial satellite on top of one of their nuclear missiles, their ICBMs, and that was Sputnik, later called Sputnik 1.
Just 4 years later, in 1961, Yuri Gagarin became the first human to journey into outer space and to complete an orbital flight.
Technological progression continued so that the rockets got bigger and bigger. They were finally able to do the first moon landing on July 20th, 1969.
Neil Armstrong reached that unbelievable milestone. He was the first human ever to walk on the lunar surface. Just 2 years later, an important new step occurred in the conquest of space. In 1971, the Soviet Union launched Salyut 1, the first manned space station to orbit the Earth. It didn't take long for the United States to launch its own space station, Skylab, which orbited Earth from 1973 to 1979. The next step was the Mir space station. It was a modular space station run by the Soviet Union and later by Russia, which was assembled in orbit from 1986 to 1996. The mission ended in 2001 when it was finally deorbited. It was the first continuously inhabited long-term research space station in orbit ever. In fact, Mir could be considered a precursor to a space colony. 1998 was a key year in the adventure of space colonization. That year, the first component of the International Space Station was launched into orbit. This space station is a joint project among European, Canadian, Japanese, and Russian space agencies and NASA. It is the largest man-made object built in space to date. It has the size of a soccer field with 72 meters length and 108 meters width.
The International Space Station is a wonderful lab, and we can do a lot of science over there, and even more. We can do inspiration to people. We can raise awareness of people by the reports of the astronauts.
Since 2000, astronauts, cosmonauts, and even space tourists from 17 different nations have continuously occupied it.
The beauty of the International Space Station is not only the research done on board, but it's especially the geopolitical aspect of the International Space Station.
All of these space stations might be considered the first steps toward future space colonization, as they have proved that we really are able to survive up there in cold, dark space. Human beings have always felt the impulse to explore and discover new frontiers. From Christopher Columbus, who crossed the ocean to discover America, to Amundsen, who traveled to the South and North Poles. There have always been intrepid explorers that dared to go one step forward to see new worlds. Now, our next frontier beyond the Earth is somewhere orbiting the Earth, or on the surfaces of the Moon, Mars, or even asteroids.
Human beings have always had the destiny of flight in their minds. And over the last 100 years, we've conquered it flying on Earth, and in the next 100 years, we'll conquer it in space.
In addition to the innate curiosity that leads human beings to always go one step further, there are other reasons to find new places to colonize beyond the Earth. The first of them is that we might really have the need, in case our own planet deteriorates so much that we can no longer live on it.
Probably most important reason why we should go into space is to safeguard our own existence. Because sooner or later, here on little planet Earth, we're going to meet an unhappy end.
People like Stephen Hawking, the well-known astrophysicist, and so many others have predicted that if we don't have human settlements in space, the future of humanity on Earth is in danger.
One of the biggest hazards that humanity might face would be the impact of a large asteroid.
We have the probability that a big asteroid might hit the Earth, like it was done in the past when the dinosaurs died out.
If an asteroid were 5 miles wide, it would cause major extinctions, like the one that may have marked the end of the age of dinosaurs. There is also the possibility of a massive man-made disaster that might obligate us to leave the Earth, as climate change or industry-linked disasters. Climate change is one of the biggest menaces we are facing nowadays. In a quite short period of time, it could cause a huge humanitarian disaster affecting millions of people. On another front, overpopulation is also threatening our civilization. As a future scenario of scarcity approaches in which there won't be enough resources for the Earth's population. In such situations, having an alternative place to live could be the only way for our civilizations to survive. But there is also a huge, powerful reason that encourages human beings to go beyond the Earth. Space colonization will bring us a new, huge industry created around new resources found off the Earth. Resources in space, both in materials and energy, are enormous. And we know that, sooner or later, we will run out of resources here on Earth as they are scarce and limited.
All the resources humans need on Earth are now in space. We have the science and the technology. We know we can capture them.
The solar system alone has, according to different estimates, enough material and energy to support anywhere from several thousand to over 1 billion times that of the current Earth-based human population.
For now, a tiny fraction of the asteroid belt is more than enough to supply a virtually unlimited material for space industrialization and space colonization.
Harnessing these resources could lead to much economic development.
At some point in the next 100 years, I expect the economy in orbit will be bigger than the economy on the ground. There's more space there. There's more material that's accessible. And there's no gravity. You can do more interesting industrial processes.
The fact that we are exploiting and using expendable resources on Earth, and those resources that are out there in space, makes the obvious conclusion we have to go.
The building of a space colony would present a series of huge technological and economic challenges. A space colony would have to be self-sufficient to be able to serve thousands of humans in an environment very hostile to human beings. Depending on the location of the space colony, whether in orbit or planet-based, there are two main types. The first type would be the space habitats, or the orbital colonies.
An orbital space colony or space settlement is in orbit. So it's actually orbiting around the sun or around the Earth or around the moon in what's sometimes called free space or low Earth orbit.
The International Space Station, or the former Mir Space Station, could be considered as precursors of these orbital space habitats. A second type of colonies would be the surface-based colonies that would exist on the surfaces of planets, moons, or asteroids. Although nowadays it seems that surface-based colonies are the best option, there are, however, certain reasons to support the building of an orbital colony. A space colony in orbit around the Earth would have many important advantages over the surface-based colonies on the Moon, or on Mars, or on asteroids. The first advantage is the proximity to Earth. Travel back and forth to Earth should take only a few hours. Bringing supplies, materials, and specialized equipment from Earth to support construction would be relatively easy. In addition, there's another advantage to being close to the Earth: the protection from cosmic radiation that is provided by the Earth's magnetic field.
If you put your orbital settlement in exactly the right place, namely directly over the Earth's equator, not more than 500, 600, 700 kilometers high, you're protected by the Earth's magnetic field. And the total amount of radiation is much, much, much lower in low Earth orbit over the equator than it is on the surface of the Moon or Mars.
However, in a very high orbit around Earth, far from the protection of Earth's atmosphere and magnetosphere, or around the Moon or Mars or an asteroid, the hazard of radiation would be extremely high. Those settlers would suffer long-term exposure to dangerously high doses of radiation. Another pro of the orbital space colonies would be the continuous, ample, reliable solar energy. In a high enough orbit, there is no night. Solar power is available 24/7 in most high orbits. Although in high, low Earth orbit, there is some darkness during each orbit as a structure passes through the Earth's shadow.
Depending on what orbit you're in, you may have better access to solar energy. Not so much in low Earth orbit, but if you're in higher orbits, you have access to solar energy.
Solar panels for settlements would have to be huge in order to generate enough power. This power might be generated on separate solar power satellites and beamed to the settlement. The construction of these structures would be weightless. Zero-gravity construction means big settlements can be built with relative ease.
Some of the advantages of orbital settlement are it's a little easier to build larger things because you're operating in microgravity.
Under zero-gravity conditions, several industrial processes can be done much more easily than on Earth. Astronauts are able to move very heavy objects, up to a few tons of weight, without any help. Therefore, the lack of gravity would radically facilitate the construction of a round structure that was several miles high without its collapsing under its own weight. A near-Earth orbital colony could also generate important economic development as it encourages new energy or tourism markets. When these future orbital space settlements grow, they would be like cities in space, places where people could live and raise children. However, these orbital settlements would have several cons.
The biggest con for orbital settlement versus surface settlements is access to materials. There aren't any materials in orbit at all.
Another con would be the permanent lack of gravity, or the microgravity, that is the gravity force one experiments in low Earth orbit, as happens in the International Space Station. The lack of gravity has very negative effects on human health, such as bone and muscle loss, vision disorders, or headaches. One solution might be to build huge circular structures that spin and create at least a sense of gravity. This artificial gravity would be created using a centripetal force. In the context of a rotating space station, it would be the spacecraft hull that provides the necessary centripetal force to simulate gravity.
So it's the concept that this thing is going to be spun at a certain rate to create a sense of gravity, which again is not a real gravity. As a matter of fact, the only thing that feels gravity is a part that's pushing against the outer surface.
There are many proposed designs and concepts for orbital space colonies. However, unfortunately, as of today, no specific project has yet been developed. There is another type of space colony, the surface-based colonies that would exist on or below the surfaces of planets, moons, or asteroids. The situation regarding these is very different compared to orbital space colonies, as there are several future plans for them. In fact, in 2010, NASA approved a very ambitious program called A Journey to Mars, whose ultimate goal is to send humans to Mars in the 2030s. In addition, ESA, the European Space Agency, has an exciting concept for a future human settlement on the Moon, the Moon Village.
There are developments underway with NASA, like the Space Launch System and the Orion capsule, to put astronauts in orbit around Mars in the 2030s.
Engineers and scientists are working hard to develop the technologies astronauts will use to one day live and work on Mars and safely return home from the next giant leap for human.
The challenges of doing a human expedition are extraordinary compared to robotic expeditions. You need to launch heavy vehicles from the Earth. You need habitat in transit from the Earth to Mars. You need propulsion to speed the rate of travel up, because it takes typically 6 months. And there's a lot of radiation from galactic cosmic rays and solar flares that are just not good for astronauts that we don't know how to shield currently.
International space agencies collaborate with the commercial space industry, such as SpaceX or Blue Origin, on coordinated expansion of human presence in the solar system, with human missions to the surface of Mars as the main goal.
And lastly, what's new in space is the proof that public-private partnership works in space. When private industry has to pay some of the costs, they're much more efficient. You get the efficiency of the private sector, you get the deep pockets of the government, and you do fantastic things.
SpaceX is a very impressive company. It was founded by an entrepreneur named Elon Musk, who really wanted to break the barriers and break the mold of the things that were stopping us from getting to Mars. And this includes both high-cost space launch, but also, frankly, the timidity of bureaucracy that's unwilling to accept the kind of risks that involve to just go for it.
This collaboration between private companies such as SpaceX and public institutions will soon produce great results in the adventure of the colonization of Mars.
So these people, the Jeff Bezos, the Elon Musks of the world, are very serious about making space work for humanity and do good for humanity back here on the Earth.
Unbelievable advances in science and technology have allowed us to achieve milestones unimaginable in the past. Regarding the Moon, everything seems to indicate that we will be witness to great advances very soon. In April 2016, Johann Dietrich Warner, Director General of the European Space Agency, surprised with the announcement of an amazing concept: the Moon Village.
The Moon Village is not a project. It is an open concept with free and open access for each and everyone, be it industry, be it the public sector. It is open for robotic activities, it's open for human activities.
It is clear that in the future, humans will take part in crewed flights farther into the solar system, so the Moon Village could also act as the perfect springboard and testing ground with that objective in mind.
I believe that the Moon Village is already in its development phase, and it's only a question of a month or let's say 1 or 2 years that we really see hardware on the Moon belonging to the Moon Village.
Building and inhabiting future planet-based space colonies means a huge technological challenge, very different from orbital space colonies. Building colonies in space would require access to water, food, space, people, construction materials, energy, transportation, communications, life support, simulated gravity, radiation protection, and capital investment.
Life support for a permanent settlement, we see in the movies that there are plants up there creating oxygen and biomass and food, and you would need that.
We're going to want to set up greenhouses, and we will take the carbon dioxide that we breathe out and some of the water that we produce, and we will use it to grow plants. And they'll turn it back into oxygen and into food for the colonists to eat.
The colonies should be located near the necessary physical resources because launching materials from Earth would be expensive. A fundamental need for the maintenance and sustainability of such space settlements would be the source of energy.
You have basically two choices at first, which is solar energy or nuclear energy.
When it comes to think about an abundant and reliable energy that we might use in a colony in the Moon or in Mars, we first think about the solar energy.
Your energy source is the sun, this enormous fusion reactor. You can't turn it off. At Earth orbit, it's supplying you with 1.377 kilowatts per square meter continuously, forever, completely reliably.
The distance of the sun is the main problem, as Mars is further away than Earth. So light intensity is much lower, and the solar energy we could benefit from is also lower. In addition to solar arrays that would need to be on the surface, there might also be large solar power satellites that would use wireless power transmission to send power to colonies on the Moon, on Mars, or other locations in space. But in places like the Moon or Mars, solar power implies another difficulty. As the supply of solar energy is too discontinuous in these locations because the moon night is 2 Earth weeks long. And on Mars, you have an atmosphere featuring large dust storms that would cover and degrade solar panels. Therefore, one possible solution could be nuclear energy.
The problem with solar energy on Mars is that it's not completely reliable. You can have a dust storm on Mars that would greatly reduce the solar power for months at a time, which could be fatal to a colony.
But energy sources aren't the only challenge we will have to cope with. Transportation to these future planet-based colonies would be also a difficult issue. Earth's force of gravity is the main obstacle faced when transporting anything to orbit. In fact, it is often the limiting factor in space endeavors.
The cost of human exploration is dominated by the cost of launching rocket propellant from the surface of the Earth up into space.
To settle space, much cheaper launch vehicles are required, as well as a way to avoid serious pollution damage to the Earth's atmosphere from the thousands, perhaps millions, of launches required. A hypersonic spaceplane with an air intake system could be one solution. Its pollution impact would be minimum, as it doesn't use any fossil fuel, but atmospheric oxygen and liquid hydrogen to reach over 5 times the speed of sound, or Mach 5. Another possible solution to make transport easier could be space elevators.
Space elevators are an idea that came about from a Russian progenitor many years ago. The idea is very simple, that if you can erect a structure that is so tall that you don't have to have a rocket ship to carry stuff, instead carry it through a tether or an elevator to the destination.
We will probably need to transport tons of materials from the Moon, from Mars's moons, and near-Earth asteroids to construction facilities located in orbital colonies.
If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration of cislunar space, human exploration of the surface of the Moon, human exploration of asteroids, and even human exploration of Mars.
Another important issue to consider is transport within the colonies. Once we are on the surfaces of the Moon or Mars, we would need local means of transport, such as lunar rovers and Mars rovers to move around.
You need a rover to drive around, to go explore Mars. You need a spacesuit that's light enough for the heavy gravity of Mars.
Not only that, but to get around for excursions, maintenance, or safety, you would need spacesuits, as the Moon, Mars, or asteroids are hostile environments for humans.
The spacesuit people wear is a spaceship to absorb radiation and prevent changes in temperature and pressure.
To establish colonies in such distant, harsh environments as the Moon or Mars will mean overcoming many challenges. Communication for a settlement so distant from Earth would be a key factor. For settlements on the Moon and in orbit, communication is not difficult. In fact, nowadays, a great proportion of current terrestrial communications already passes through satellites. Nevertheless, for future, more distant colonies, communications become a difficult-to-solve issue. Transmissions to and from Mars suffer from significant delays due to the finitude of the speed of light and the greatly varying distance between conjunction and opposition, the closest and the furthest distance between Mars and the Earth.
To Mars, it can be as short as around 4 minutes, or as long as 20 minutes. Once in a while, if Mars goes behind the sun, you can't talk to Mars at all.
Nevertheless, future colonists would have no problem with other means of communication that do not require live interaction, such as email and voicemail systems. Any of the future colonies, whether on Mars, on the Moon, on asteroids, or an orbital space station, is going to mean coping with high levels of radiation, extreme temperatures, the lack of oxygen, and the lack of resources in general. On Earth, we have a perfect life support system supplied by a huge and complex biosphere. In space settlements, which are closed and relatively small systems, if we want to ensure a life support system, we will have to recycle or import all the nutrients to avoid its collapse. The closest terrestrial analogy to space life support is possibly that of a nuclear submarine. The challenge of mechanical life support systems in a nuclear submarine is to support humans in closed, small spaces for months without surfacing. This same technology might be employed for space use. Therefore, building a space colony will undoubtedly be one of the biggest challenges humanity has ever faced.
An expedition that's relatively short-lived for science and comes back to Earth, that's a little bit easier. But if you want to sustain civilization on the planet, then you have to figure out how to deal with these issues.
There is, however, still one issue without which we won't be able to survive out there: protection from radiation.
In fact, space is a seething cauldron of very dangerous radiation that comes from two sources. One is galactic cosmic radiation that comes from all directions at once, and the other is solar radiation that comes from the sun.
Cosmic radiation is a hazard. So in low Earth orbit in the International Space Station, we're largely protected by Earth's magnetic field. But as soon as you go to deep space, what's happening is there are particles coming in from the cosmos called galactic cosmic rays, and they go right through the spacecraft walls. And sometimes they collide with them into a shower of other particles, basically protons. And they go right through the flesh, and they can disrupt the DNA.
In environments with no protection to that lethal radiation like the outer space, or the Moon's surface where there is no atmosphere at all, or the surface or Mars with an extremely thin atmosphere, the life would be impossible.
The surface of Mars we've studied in many locations, it's so exposed to radiation and ultraviolet light that even organic molecules are completely destroyed.
Settlements as well as spaceships during the long journey to such distant destinations must be surrounded by sufficient water mass or other materials to absorb most incoming radiation to protect life.
So to protect you for this in a colony, you could have a safe haven. Water, I believe, is a good detector. So if you had a space colony, you could arrange, for there to be either safe rooms or the water storage could be in a strategic location.
In addition to all the challenges we have to overcome to get to our destination, there is one other that we must take into account: the effects of spaceflight on human health. If we want to go to a lunar colony, we would need to travel through space for at least 1 or 2 days with present technology. However, to go to Mars, the journey would take much longer, between 6 and 9 months. Such a long spaceflight would mean very long exposure time to cosmic radiation and to zero gravity, with the subsequent negative effects on human health. In addition to that, a mission of such long duration can carry several psychosocial problems. The solitude that astronauts suffer can generate claustrophobia and depression. In the same way, lack of sleep and monotony may affect the correct performance of tasks that in such a demanding work environment would require extreme precision. Most of the detrimental effects on the human body are related to being exposed to the lack of gravity during long space flights. There are significant adverse effects, which include muscle atrophy and deterioration of the skeleton, which is known as spaceflight osteopenia.
We know that 0G for a considerable length of time doesn't work. You end up with a lot of problems.
The top 3 complaints in space for health are headaches, backaches, and poor sleep. I believe in that order, although it's different for everybody.
Other significant effects, including a slowing of cardiovascular system functions, decreased production of red blood cells, balance disorders, eyesight disorders, and a weakening of the immune system.
You don't have the gravity pulling on your bones, so you'll lose, say, 1% of your femur, your hip bone, every month. It just gets absorbed back by your body because you're not using it as much.
And your bones start losing calcium almost immediately and continue to lose calcium throughout the flight, no matter what the duration is.
So you have several liters of fluid from your lower body that float into your upper body. And if you look at the astronauts on TV, you'll see their faces are rounder than they should be. And that's literally extra fluid that's floated from their legs into their upper body.
These effects happen in zero gravity or microgravity, but on the Moon or Mars, there would be some gravity, so consequences on human health would be different.
So the Moon has 16.6% the gravity of Earth. Mars has roughly 30% the gravity of Earth, 33% the gravity of Earth. We do not know what the human body does with this amount of gravity. We literally have no idea.
Learning to live outside the Earth will be one of humanity's greatest milestones, and it won't be an easy task at all. Engineers and scientists from all over the world are working to develop the technologies that will lead us to be able to establish our first home off Earth. In fact, there are several projects from public institutions and private companies that will kick off the future real colonization of space. Among all the colonization projects, there are some that have focused on taking advantage of using the resources on asteroids. In fact, these could be considered the first real step toward an imminent future space industrial revolution.
The asteroids are the key to an affordable program of human exploration for our civilization. So the main advantages of the asteroids for human settlements is that they allow us to engineer worlds in space that provide all of the needs for human habitation.
The first aim of the colonization of the asteroids would be the mining. Asteroid mining is a proposed industrial process in which asteroids are mined for valuable materials, as rocket propellant or certain raw materials or metals that are scarce on Earth.
We concluded that the asteroids were the best place to mine for delivering material to Earth orbit.
The asteroids right now are known to be the greatest resource of mineral resources. Economically, one asteroid could produce $1 trillion worth of revenue over a short period of time, mining it and transporting it to Earth. And there are companies seriously planning to go out and capture those. The interesting thing about the asteroids is that that kind of research can combine efforts to avoid asteroid collision with Earth. At the same time, we're mining them to get the resources for Earth.
The asteroids are a goal for space resources for two reasons. One, in terms of the energy and rocket propellant required to get there and back, they're the most accessible targets beyond low Earth orbit for humanity. Two, they have many valuable materials that can be used in space. The first valuable material that we'll harvest from asteroids are the ingredients in rocket propellant. If we can turn the asteroids into refueling stations in space, we can dramatically drop the cost of human exploration.
The main asteroid belt between the orbits of Mars and Jupiter and the so-called Jupiter Trojans, which are co-orbital with Jupiter, are the places where most of the known asteroids are located. In addition to those asteroids, there are other orbital families of asteroids with important populations, such as the near-Earth asteroids, which have orbits close to Earth. Up to date, several missions have been sent to visit some of these near-Earth asteroids. The first one to be visited by a spacecraft was asteroid 433 Eros, when NASA's Near-Earth Asteroid Rendezvous probe landed on its surface in February 2002. A second near-Earth asteroid, 25143 Itokawa, was visited in 2005 by the Hayabusa mission of the Japan Aerospace Exploration Agency, JAXA.
So the Hayabusa mission, which was performed by JAXA, went out to the asteroid Itokawa, and they actually took a very small sample from the surface of that asteroid. It was a little less than 1 milligram of material.
The fact that asteroids are small rocks floating in space offers several advantages, but also some disadvantages. One of the greatest advantages is their low gravity because of their small size, which means an important reduction in the costs and risks of landing in comparison to the Moon's or Mars's higher gravities. This fact also makes the construction of structures much easier. The fact that there are over 300,000 asteroids identified to date is another pro, as there would be a large number of possible sites.
There are asteroids everywhere in the solar system. I mean, literally everywhere. Not every single location, but there are asteroids here and there.
It's known that there are carbon-rich, metallic, and stony asteroids. This variety in their chemical composition makes them potentially useful as materials for building or fueling spacecrafts. Material mined from asteroids could be a basis for trade economy, and precious metals may even be returned to Earth or other colonized worlds from asteroid mines for economic gain.
And with public-private partnership, we can build the infrastructure that moves industry in space, not in 20 or 50 or 100 years, but starting in 3 or 4 or 5 years. And we can be harvesting rocket propellant in less than 10 years and building the transcontinental railroad to the solar system.
Many asteroids contain large amounts of water and other volatiles, as well as carbon, all of which are necessary for life support.
The ones that we're going to be interested in first are what we call carbonaceous chondritic types. And the magic constituent that they have that we're going to be after is water.
These resources could also be transported to other places in the solar system where they are scarce, and at a much lower cost than launching such materials from larger bodies such as the Moon or Mars.
We get better space propulsion utilizing the asteroid volatile material, the water and carbon dioxide, which we can convert into rocket fuel. We'll have more mobility in space, and as that happens, we'll go further and further into the solar system. And that's the first small industrial scale mission to bring back an economically important quantity of rocket propellant that can change the economics of space.
However, to make this future mining industry a reality, we should solve several challenges, such as the asteroid's low gravity and zero atmosphere, which make them vulnerable to cosmic radiation and to the impact of small objects. There are several private companies interested in mining asteroids. On 2012, the private company Planetary Resources announced a plan to harvest resources from asteroids. The plan has a few opponents who doubt the profitability of the operation, as the cost of extracting resources like precious metals, no matter how abundant they are in the asteroids, would be much higher than its extraction cost on Earth.
There are some materials that potentially could be of use on Earth. Platinum group metals is usually mentioned. It, however, is very difficult, at least now, for asteroid mines to compete with Earth mines.
Nevertheless, Planetary Resources thinks that the plan will be profitable if they are able to develop technologies that reduce the costs of spaceflight. One way to reduce those costs would be the creation of space facilities such as propellant production plants. The asteroid mining company TransAstra is betting strongly on a plan to produce propellant using the water contained in asteroids. Molecules of water would be split into their atoms of hydrogen using solar energy.
TransAstra has a business plan that's focused on extracting rocket propellant from asteroids. You could call that asteroid mining if you want. And then using that rocket propellant to fill refueling stations in space, to refuel NASA spacecraft and private sector spacecraft.
Another very promising asteroid mining company is Deep Space Industries, founded in 2013.
So Deep Space Industries is an asteroid mining company. We expect to be mining asteroids in somewhere in the next 6 to 10 years.
Its goal is to provide the technical resources, capabilities, and system integration required to prospect for harvest, process, manufacture, and market in-space resources.
So when we look at which asteroids that we want to mine, we're looking at several different things. We want to know that they have the materials in them that we can extract and that they're relatively easily extractable. But one of the biggest things is accessibility. They have to be relatively close to the Earth.
Nowadays, there are several projects led by public institutions and private companies, such as SpaceX, Blue Origin, or these asteroid mining companies that show that future expansion of human beings beyond the limits of our planet is not so far in the future.
We stand at a very important time in history. There have been a few important changes that have occurred in the last few years. One, for the first time we know that there's valuable water and other materials in the lunar poles and in the highly accessible asteroids that can be used to make very cost-effective rocket propellant to make it much less expensive to do deep space exploration. 2, we now have the technology to build fully reusable, very affordable spaceships. Elon Musk and Jeff Bezos are leading the way in that way. They're starting off with fully reusable rockets that launch into space. It's very obvious that the next step is fully reusable spaceships that stay in space and fly the space line. But those fully reusable spaceships in space will require rocket propellant, and we'll get that from the lunar poles and the asteroids.
We might be on the verge of witnessing a new whole revolution that will change the world as we know it now. The space colonization race has just begun.